fashion clothing business. These are the offcuts. And these are the cut-offs. Fashionable now, but they'll be thrown out in 6 months' time. A lot of industrial waste, however, cannot be recycled and is simply thrown out. It's poured into the sewers, the rivers, or the atmosphere. We could be drinking it or breathing it in. So, is it doing us any harm? Is it damaging the environment? How can we find out? Difficult questions, because we don't fully understand how the environment works. A simpler, closed system like bacteria growing in a Petri dish might give us a clue. Watch these bacterial colonies. Their rate of growth changes dramatically with time, and the way in which the rates of growth change provide important information about the bacterial environment. So what's going on here? At first, the bacteria grow rapidly, like these seen under a microscope. But the rate of growth gradually slows down and then stops. Did the bacteria run out of room or food? But they stopped growing long before the available space or nutrients were used up. So why have they stopped growing? This culture contains a red indicator dye that turns yellow when the pH falls. Watch the bacterial colony growing. What effects are the bacteria having on their environment? We'll take this growing colony from the culture on the left and add it to the older culture in the Petri dish on the right. How do you think the new colony will react? When the new colony is placed in the old culture, it stops growing. In the closed system of the Petri dish, the limits to growth are the bacteria's own waste products. The real world, however, is much larger than a Petri dish. It's much more complex and unpredictable. So does the Petri dish experiment have any relevance to our world? In Thailand, and in many of the Far Eastern countries, fish are an important part of the national diet and an essential source of animal protein. These fishermen are harvesting tilapia, a fast-growing fish that thrives in this part of the world. But the extraordinary thing about these fish farms is that they are part of a closed system in which ducks make 3 important contributions. Their meat and their eggs provide a valuable food source for the community. So what's the third purpose of these versatile birds? The ducks' other contribution to the integrated farm is their excreta, which fall through the slatted floor into the water below. This encourages plant growth, which provides food for the ducks, and it also feeds the tilapia fish. Like the Petri dish, this is a closed system. But these communes control the level of waste in their environment by recycling it. At the same time, they are making the most of their scarce resources. In this fish farm, a high-protein concentrate is fed to the trout, which are kept in artificial ponds. There is no recycling here. The trout are very sensitive to water quality and require a constant flow of clean water through the ponds. Even a very small reduction in levels of dissolved oxygen in the water stresses the fish. You can see the trout's breathing rate increase as it tries to maintain its oxygen intake. How many ways can you think of for measuring water quality? This farm is an open system. Uneaten food and waste products are carried away into this stream. But the stream drains into the lake. If the lake was a closed system, then the waste generated by the fish farm could eventually become a serious source of pollution. So, is the lake a closed system? The lake is an open system, and it drains into this river. Perhaps we should measure pollution in the river. One way of doing that is to look at the species that live in it. This is Gammarus, a freshwater shrimp. It's a scavenger and eats dead and decaying material. So does Acellus, the freshwater louse, another scavenger organism. And this is the dragonfly nymph. Lately, the number of nymphs in British rivers has fallen, while Gammarus and Acellus have increased their numbers dramatically. So what do you think that means? The dragonfly nymph is highly sensitive to levels of dissolved oxygen in the water. If levels of oxygen fall, the nymphs eventually die off. Gammarus and Acellus are less sensitive to the quality of the water. They are the staple food of the nymph. And as the main predator dies off, they increase in numbers. These population shifts were due to increased sewage pollution, which stimulated the growth of aerobic bacteria, which began to use up the oxygen dissolved in the river. The dragonfly nymph dies. Its former prey, the Gammarus and Acellus, thrive. But as oxygen levels continue to fall, they die off as well. Now only the worms remain, until oxygen levels drop so low that they too die off. Finally, the aerobic bacteria themselves are killed, starved of the oxygen they need. Anaerobic bacteria take over. Now the river is stagnant, smelly, and full of dangerous disease-causing bacteria. How would you return the river to its former condition? The river opens into an estuary, and there is pollution here too. The different coloured dots show the presence of copper, hydrocarbons, and a saltwater fish, the flounder. Where are the sources of pollution, and what effects are they having on the fish? Copper is associated with 3 coastal sites. East and west are 2 sewage outlets, where copper salts are partly derived from copper plumbing. The middle location is an oil refinery, which uses copper salts in a cleaning process. This refinery is also associated with hydrocarbons, as are 4 other oil storage depots. The flounder is keeping to the clean water where the estuary opens out into the sea. Pollution in the rivers ends up as pollution at sea. We tend to take less notice of that. It's further away. And there's the dilution factor. Levels of pollutants at sea are usually much less than they are in rivers or estuaries. We've been using the seas as a vast rubbish dump for centuries. But how much longer can we get away with it? Here are the raw fish data. Hard to swallow in this form. So how about a little cookery? In the North Sea, heavy metals and pesticides, such as DDT, are thought to have caused an increase in disease in free-swimming fish, such as mackerel. Why should bottom-feeding fish, such as plaice, be more severely affected? And is the sea an open system? Remember, in the Petri dish, the bacteria eventually killed themselves as levels of their waste products built up in their closed environment. From the rivers to the estuaries and seas, each system that we think of as open is merely a small part of the closed system that is the Earth. Increasingly, strategies of waste management must take this into account. In London alone, baths and showers, lawn sprinklers, car washes, not to mention cups of tea, use up 50 million gallons of drinking quality water every day. But London's reservoirs can only supply 35 million gallons of fresh water a day. So where do we get the other 15 million gallons from? In a word, sewage. Each loo flush pours 1.5 gallons of water into the sewers, which eventually arrives at a sewage processing station. This is one of the most modern in the country. Raw sewage arriving at the sewage station must first be lifted by these massive Archimedes screws up into the primary processing area for gross filtration and sedimentation. In the next stage, the sewage is activated. These propellers aerate the liquid so that aerobic bacteria can thrive and break down the organic content. Then, into the final sedimentation tanks, a last filtration, and you're left with pure water, which can be returned to the water system. Impressive engineering, but it all relies on microbiology. The process begins with aerobic bacteria, such as these spirochetes. They live in the activation tanks where they break down organic materials such as urea and cellulose. In the next stage of this microscopic food chain, the bacteria are eaten by ciliates, such as this Vorticella, and other multicellular creatures, such as the rotifer, or this small motile gastrotrike. The microorganisms are eaten by midgefly larvae, nematodes, and small worms like these at the top of the food chain. The water is by this stage free from dangerous bacteria. All these organisms are found in most inland water and form a naturally occurring self-cleaning mechanism. An overload of sewage, however, will kill many of these organisms off by reducing the oxygen content of the water, which is why the sewage station uses these aerating devices, so that the aerobic bacteria can thrive and support the rest of the biological chain, which eventually produces our drinking water. The seas aren't the only communal rubbish dump, or even the biggest. That, of course, is the atmosphere. And here, too, there are danger signs. Too many cars, lorries, factories, power stations, all releasing exhaust fumes and smoke into the closed system of the air. These fumes contain carbon dioxide and sulfur and nitrogen compounds, which combine with water vapor in the atmosphere to form acid rain. The burning of fuel, whether petrol, coal or stubble, also releases clouds of particles of carbon and other substances into the air, some of which can cause cancer. So, how can we filter them out of the atmosphere? The bad news is we already do. Every breath you take inhales dust and smoke deep into the lungs. Through the microscope, you can see this man's lungs are full of black specks of carbon. A prime cause of this sort of atmospheric pollution is the internal combustion engine. How can the car be made less environmentally damaging? The internal combustion engine produces large amounts of the toxic gas carbon monoxide, unburnt hydrocarbons responsible for smog, and nitrogen oxides which contribute to acid rain. This factory is producing catalytic converters. They contain the catalyst platinum in a ceramic honeycomb. They are welded into steel casings before being fitted into car exhausts. Each cat will cut the pollutants in a car exhaust from half a ton a year to about 45 pounds, although they will not reduce the amount of carbon dioxide produced or help the greenhouse effect. Will it be enough to make car engines cleaner? Or will we have to reduce the number of cars on the road? Can the car ever be environmentally acceptable? Or does the future lie with public transport? Probably one of the safest ways of disposing of waste is to bury it deep underground, out of sight and out of mind, perhaps for centuries. And that is certainly achievable, provided that the land has been properly surveyed and the infill site is well maintained. Here at sunny Brogborough, rubbish from the southeast is being tipped into the immense hole in the ground that was left behind when the clay was dug out to make bricks. Here's a load of clay now, going to the kilns. So there is a kind of recycling going on, but that's not the whole story. As organic rubbish decomposes, it gives off the inflammable gas methane. If methane is allowed to build up, it can reach explosive concentrations and on some uncontrolled sites has caused substantial damage. Here at Brogborough, however, the methane is carefully collected and piped to a generating station where it is used to fuel electrical generators. The electricity doesn't go far, just across the road in fact, where it is used to heat the kilns of this brick company. Here they bake the bricks that make up the homes of most of the southeast, whose inhabitants generate the rubbish that comes back to Brogborough. And so, the circle is complete. Going round in circles just may be the way forward.